All right, here we go. Next video. As I walk you through the answer keys, this is the answer key to the mixed stoich review that you just got off of the Loom lessons. A couple things that I want you to have out. You should have your roadmap, all right? So we're gonna kind of walk through where we are starting on the roadmap and where we are ending on the roadmap, and how the definition of stoichiometry is when we go from moles of A to moles of B. So we're gonna have to be in moles to go from A to B. So you should have out your roadmap. I also have out a periodic table, so I can use that to get my molar masses. I did do those in advance just to save us a little bit of time. I also have a calculator out, so I can do some calculations. So let's go ahead and get started then. I have my balanced equation. I know that my number of moles, which are my coefficients, are listed there. So I have 1 mole of copper nitrate, 2 moles of sodium hydroxide, 2 moles of sodium nitrate, and then 1 mole of copper hydroxide. So when I look at that problem, I just want to first start with the number I am given. So in problem number 1, I'm starting with 2.50 moles of the copper nitrate. So I'm going to set that over 1. Now, looking at my roadmap then, using my roadmap, I am in moles of substance A. That's a good spot to be in. I can immediately go to moles of substance B. So if you are in moles in your next fraction, you can use the ratio, the number of moles, the coefficients, to go from A to B. So copper nitrate is on top, so I'm going to use copper nitrate. So I have 1 mole of copper nitrate. Whoops, NO3, 2. So I have 1 mole of copper nitrate. I am going to copper hydroxide. I have 1 mole of copper hydroxide. All right, so I'm starting in moles and I am ending in moles. So that is 1 jump, starting in moles of substance A, ending in moles of substance B. Now, when you do the math here, I'm gonna multiply the top, divide by the bottom, making sure that my units cancel. So I'm gonna multiply by 1, divide by 1, my final answer, 2.50 moles, but now I am in copper hydroxide. So the point of stoichiometry is to convert from substance A to substance B using a balanced equation. Okay? So I am now going to go to problem 2. Again, I'm going to start with that first number. So I'm starting with 1.55 grams of copper nitrate, and I'm starting over 1. Now, ideally, I would be in moles of copper nitrate, so I can go from substance A to B. I am not. I am in grams. All right, so my first step is I'm going to have to use the molar mass off the periodic table to go from grams to moles. So in this first fraction, if grams of copper nitrate is on top, grams of copper nitrate is on the bottom. So I used my periodic table. There's 187.5 grams of copper nitrate per 1 mole of copper nitrate. Now, remember that 1 mole is not because there's 1 mole in that balanced equation. That 1 mole is because this is off the periodic table. So anytime you convert from grams to moles, again, I wrote that as the reminder, 1 mole. You have 1 mole of copper nitrate. So I have now converted from grams of copper nitrate to moles. I am now at a good point in my roadmap that I can do the stoichiometry. I can jump from substance A to substance B. Again, just aligning my fractions. It will remind you, use the coefficients. So I have 1 mole of copper nitrate from the balanced equation. I am still going to copper hydroxide, 1 mole of copper hydroxide. So now my nitrate has canceled, leaving me in an answer in moles of copper hydroxide. I'm going to multiply the top, divide by the bottom, and I get an answer of 0.00826 moles of copper hydroxide. So this is stoichiometry because I started in a nitrate, I'm ending in a hydroxide. And stoichiometry is that mole to mole jump, that A to B jump that takes place, but only after you've converted to moles. So by setting up that first fraction, that tells you where you are on the roadmap. Okay, so that first fraction is an important fraction because it identifies your location on the road map. All right, so we got two more here real quick. So for the next one, for problem number 3, again, I'm gonna take my first number. So it is 0.81. In moles, always excited when I see moles at the start of a stoichiometry problem, because again, that means I can immediately go from substance A to substance B in my stoichiometry. All right, so according to the balanced equation, I have 1 mole of copper nitrate. I have 1 mole of copper hydroxide. So there is that A to B jump. I am now done with my nitrate. I am in my hydroxide. Now this could be the end of the problem because you have done stoichiometry. You've started in A and you've ended in B. However, there's that one extra step. Now they want this answer in grams. So I'm gonna use the molar mass off the periodic table, again aligning my fractions. For every 1 mole of copper hydroxide, again, I just used the periodic table. There is 97.55 grams of copper hydroxide. And now I can do my math. Now, remember, this is 1 mole, not because it's in the balanced equation, but because I'm using the periodic table. So the coefficients are only used 1 time to make that A to B jump. Otherwise, you go back to 1 mole when you're using the periodic table. So I multiply the top. I don't need to divide by the bottom. My final answer for problem 3, 79.02 grams of copper hydroxide. All right. Now, this last one we're gonna do, this is all 4 jumps. So we're gonna start in grams and end in grams to grams. To do that, we need to convert to moles. So we can go A to B and then back to grams. So again, I use that starting fraction. So 120 grams of the copper nitrate. And I tried to be consistent with the substances so you didn't have to continually re-add up molar masses. So I'm starting in grams. I have to convert to moles to go from A to B. So again, using my periodic table, there's 187.55 grams of copper nitrate per 1 mole. And again, it's 1 mole because I'm using the periodic table. Now that I'm in moles, substance A to substance B. So I have 1 mole of copper nitrate. I have 1 mole of copper hydroxide. This is the stoichiometry. That is your A to B conversion. And I could be done if they wanted the answer in moles, but they do want 1 extra step. They do want me to go to grams, so I'm gonna go back to 1 mole. Again, not because it's 1 mole in the balanced equation, but because of the fact that I am using the periodic table. So for every 1 mole of copper hydroxide, there's 97.55 grams of copper hydroxide. So just using that periodic table. So I now can multiply the top, so 120. I'm gonna multiply that by 97.55. What a lot of people will do is they'll forget to divide by the 187.55. So multiply the top, divide by the bottom, make sure all your units are canceling, which they are, giving us our final answer in grams of copper hydroxide. It is 62.42 grams of copper hydroxide. All right. So hope this video helped. If you have any questions, make sure that you send them off to me. But hopefully, again, this is a good way to end the week, a nice check-in. Make sure we're understanding the problems as we head into next week when I see you again. Have a great rest of the day. I'm gonna try to stop this from my phone.